First, let's discuss how AV signatures stored, not just how they work. And the reason it's important because, as I mentioned before, back in the day, the amount of resources were very scarce. The internet was slow and the amount of RAM every machine would have would be very limited. That set a very tight restriction on how big antivirus signatures could be, especially if we want to update it on a regular basis. You couldn't just take a 500 megabyte of RAM to load your antivirus signatures, as well as you couldn't just download 100 megabyte a day of updates. That would not be acceptable in that period of time as well. The signature must have been very elegant. So to solve this problem, instead of storing the whole binary string of the signature, for example, by some reason you decide to create a really big signature, what you could store instead of this big signature is two things. You could store a bit mask where each bit would represent a byte in a binary string, right? So that would be 8x times smaller, because each byte has 8 bits. And you would have very simple hash, usually would be CRC32 or something like that, of those bytes. So instead of storing that large string, you would store these two like a smaller elements, right, to optimize the data storage. And another very important thing, the signature would almost never be based on just a large string, byte string. Instead, the signature would consist of 2 or 3 much smaller elements. And you would say, didn't I say that if signatures are very small, let's say the first one 4 to 6 bytes and the second one to 32 bytes. Antivirus would first search 4 to 6 bytes on very short sequence, and of course, as I mentioned, it wouldn't actually search for bytes, it would search for some sort of CRC32 or 16 or some other very fast simple hashing mechanism. Signature would tell that if this first small sequence of bytes triggered, only and only then you search for this longer sequence of bytes. That's our first sequence of bytes, and that's our second sequence of bytes. So only if the first one triggered, it would give you information where to search for the second signature. The way to search could be implemented very differently, and how exactly that would be implemented we'll discuss in the next slide. It would be called 2-point or 3-point signature, where it can have 1, 2, and maybe even 3 sequence of bytes we're looking for, and each of these sequences can be represented by CRC32 or some other simple short hash, right? And only if the first one triggers, it would search for second one. Only if second one triggers, it would search for the third one in specified location where it needs to search for that. So instead of trying to put a lot of bytes into the signature, like hundreds or thousands of bytes, very carefully antivirus expert would choose a sequence of bytes which represent an important part of the algorithm which won't change easily, right? Most likely at that time you wouldn't just select a random string or like any kind of string. You would focus on the code itself, and you pick the specific parts of the code. Yeah, so the antivirus signature database would contain a bunch of signatures like that, maybe hundreds, maybe thousands at some point, and there would be this chained signature where it starts from a very small snippet, and only the first snippet triggered, it searched for the second and third. However, antivirus engine wouldn't scan for this first snippet the whole file. First of all, that snippet is small, and also it's very slow, and it would require multiple rescans to first search for first snippet, and then search for second snippet, and search for third snippet. Let me explain you how exactly the searching for those byte snippets worked. Now you know how AV signature looked like and how they were stored in antivirus database. In the next video, let's discuss what kind of strategy antivirus engine would use to apply such signatures efficiently and to avoid false positives.